review where we left off on chapter 15 last time. Your parasympathetic, which your book has in purple, and your sympathetic in green. Long preganglionic, short post, and that's your parasympathetic. Why? Because these nerves come out of your brain and your butt. Got it? Out of the sacrum. And then you have your short preganglionic, long postganglionic, or your sympathetic. And remember that because this is your sympathetic chain ganglia running down the side of your spinal cord. Okay? Now, let me ask you a question. Are these heavily or lightly myelinated?
Lightly.
Lightly. Why?
Because it doesn't have to be quick.
Exactly. I don't need it to go as fast as electricity can go, 100 meters per second, because this is not life and death. This is, hey, telling your heart to beat faster, telling your stomach to digest faster. That doesn't require a life and death quick. It's still an action potential. It's got to go all the way down the neuron. It's still an action potential, but it doesn't require it to be that fast. That's why it's intermediate size and lightly myelinated. Okay? It's type B neuron. All right, so let's carry on from this. Who are your parasympathetic nerves? Notice, they're also called craniosacral. Yeah, because they come out of your brain and your butt. Alrighty? Your ocular motor, your facial, your glossopharyngeal, and of course, number one, the vagus. Alrighty? And down here at the bottom is from the sacrum. Alright. Two very important words. Put a big star by these two and make sure you know them. Cholinergic, adrenergic. Let's first explain what the parts of the words mean. The first part I want to make sure you understand is ergo. Ergo, E-R-G-O, means work. Okay? Have you ever heard of an ergonomic chair? Ever heard of an ergonomic desk? Okay? Where do you find ergonomic chairs and ergonomic desks? At work, right? It's an adjustable chair or an adjustable desk or an adjustable, computer screen or something. Got it? To accommodate the worker. Why? Because the employee wants to make sure work is, really, really, really easy and pleasant? No. It's to make sure that you can get more work out of the worker without them getting carpal tunnel syndrome, without them having a bad back. Does that make sense? So you want to be able to adjust the chair to accommodate, or adjust the desk to accommodate your workers to get more what out of them? More work. That's why it's called ergonomic. Okay? All right, now, so these are neurons that work with, what do you think? Acetylcholine. So would those be parasympathetic? Yes, because the parasympathetic works with acetylcholine, right? Okay. How about this? Adrenergic works with, I wonder what that word could be. Adrenaline. What's adrenaline? Epinephrine and norepinephrine. So those would be sympathetic. See how that works? If you're using acetylcholine, you are a cholinergic neuron. If you're using norepinephrine as what you're releasing, you are an adrenergic neuron or fiber. Okay? Now, let's put two and two together. What kind of receptor would I be using for this? Yeah, well, what kind of receptor would that be? A cholinergic receptor and an adrenergic receptor. Does that make sense? That's it. So it's not difficult as long as you understand what the adreno part is, adrenaline, and what the ergo part is. You got the choline part. Okay? So that's how we're going to use them. Alrighty? Yep, here you go. See? Cholinergic receptors for acetylcholine, adrenergic receptors for norepinephrine or epinephrine. Remember, they're cousins. All right? Should I know this? What do you think? Yeah. Okay. Now, let's make sure we apply that to this picture. Remember, I told you this is the most important picture for this part, for this chapter. Let's apply that. Using just those two words. What kind of neuron is this? I'm only using these two words. What kind of neuron is this? Does it make sense? Because what's it releasing? Acetylcholine, okay? Now, what kind of neuron is this? Cholinergic. What's this one?
Adrenergic.
Adrenergic. What's this one?
Cholinergic.
Cholinergic. What's this one?
Cholinergic.
What's this one?
Cholinergic.
So, how many cholinergics do we have up here? 1, 2, 3, 4 of the 5. We only have, well, 4 components. 1, 2, 3, 4, okay? Don't worry about this one so much. And this, because there's only one adrenergic. It's not the first, it is the second sympathetic neuron. Got it? Because everybody else uses acetylcholine all the time. Are you with me? There's only one guy that's different. So what's easier to remember? What everybody does, or the fact that there's only one that's adrenergic and everybody else is cholinergic? Which one is the easier way to remember this? Does that make sense? That's what I'm saying. There's always two ways to learn stuff. The hard way or the easy way. Okay? All right. Let's step this up a little bit. The cholinergic receptors, the ones that receive acetylcholine, are classified as two types. Nicotinic and muscarinic. Nicotinic and muscarinic. So that would be a flashcard for me. Nicotinic and muscarinic on one side, on the other side, acetylcholine, ACH. That's who uses it, all right? And keep looking at it till you don't forget that. What do I need you to know about nicotinic and muscarinic? That they are either stimulatory or inhibitory. When acetylcholine lands on that receptor, it's either going to send the message on or it's going to stop that message. It's going to be a message of go, 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 or a message of don't, don't, don't. Are you with me? So, this is why they named them these two words. Now, I don't smoke, so I can't, attest to this personally. But what is nicotine? A stimulant or a suppressant?
Stimulant.
It's a stimulant, okay? It was originally put into all of the K rations for people in World War II. Along with their MREs, meals ready to eat, you also got cigarettes. Anybody know why? Because if you ran out of food, you would smoke a cigarette to keep you from being hungry. And that's why so many guys came back from World War II hooked on what? Cigarettes. Are you with me? Okay. So, my dad was one of them. So, guess what? Nicotinic receptors are what? Stimulatory. Got it? They're going to keep the message going. Now, muscarinic. Have you ever heard of muscadine grapes? What can you make from muscadine grapes down here in South Carolina?
Wine?
Wine. Is wine a stimulant or more of a depressant?
Depressant.
Got it? So this is more of a inhibitory. Are you with me? So think about smoking and drinking. Yeah, two things we shouldn't be encouraging, but there it is. Are you with me? Okay. Nicotinic receptors are found on the motor end plate of a skeletal muscle to make sure you tell the muscle to contract. All the ganglionic neurons, remember the first ones, because we got to move it from the first preganglionic neuron to the postganglionic neuron, don't we? So that's all going to be nicotinic. And of course the one for the medulla of the adrenal gland. All right? The effect of acetylcholine on the nicotinic receptor is what? Always stimulatory, because we just said smoking is a stimulant. Nicotine is a stimulant. Okay. Now, what about muscarinic? Muscarinic are going to be found where? At the postganglionic neuron, because it's either going to be inhibitory or excitatory, but here's the most important thing you need to understand. It is definitely inhibitory to the heart. Remember, we said acetylcholine is part of your parasympathetic, and when acetylcholine hits your heart, it's to slow your heart down. Got it? So that's why the muscarinic on your heart is inhibitory. But how about the smooth muscle? No, it's actually going to stimulate that to squeeze. Because doesn't parasympathetic tell your digestive system, made of smooth muscles around your intestines, to squeeze? Okay. So, the only one we can say is always stimulatory are the nicotinics, because the muscarinics can be one or the other. So what do I need to know for the test? That it's inhibitory here, but it's stimulatory because it's part of rest and digest. Rest, slow down, digest, speed up. Does that make sense? Okay. Now, how about the adrenergics? Well, I wish they'd come up with something a little more exciting than A and B. But that's all they got. Alpha and beta receptors. Alpha meaning A, like the letter A in the Greek alphabet, and B. Alrighty? Nothing special. When we get to nursing school, and I hope to see all of you there, you'll be learning that there are subtypes. Alpha 1, alpha 2, beta 1, beta 2, and beta 3s. At this point, no. What do I need you to know? That your alpha receptors are generally what? Stimulatory. Got it? So when epinephrine or norepinephrine lands on an alpha receptor, it's going to do what? Stimulate. Make that effector do more. Alrighty? And in general, when it gets to the beta receptor, what are we going to do in general? Inhibitory. Got it? Stimulatory, inhibitory. Kind of, just like we see here. Stimulatory, mostly inhibitory. Got it? Okay. Now, do I see something with an exclamation point and in bold print? There is a notable exception. The beta receptors on your heart are also stimulatory. Got it? Both the alphas and the betas tell your heart beat faster. Okay? Now, have you heard of somebody being on a beta blocker? Okay? You're looking at one. I'm on a beta blocker. What does that mean? I'm blocking betas. No, I'm not. I'm blocking epinephrine from getting to the beta receptors of my heart. Got it? So, my heart's not going to completely stop because I still have what on my heart? Alpha receptors. But my doctor wants to make sure that my heart doesn't overreact to adrenaline, and therefore it's going to block half the adrenaline. Got it? So my heart doesn't beat as fast. Does that make sense? All right. And that's because my heart's been damaged from the heart attacks that I've had, and my heart can't afford to go really fast. 10-4? Okay. How are we doing? Now, let's just put 2 and 2 together. Where else do you think there are beta receptors that are inhibitory when epinephrine gets there? Or norepinephrine? Where do you think in your body, when you're in fight or flight, what part of your body is told to shut down?
Digestion?
The digestive system. So that's where those beta receptors are, is on your digestive system. Because epinephrine says, hey, slow down. Are you with me? Okay, but not my heart. It says heart speed up. So I'm on a blocker to make sure I don't speed up. 10-4. My resting heart rate is around 70 or lower than that, 65. And when I have to do my nuclear stress test, they want me to get above 145. Got it? Well, like an idiot, I forgot and took my medicine that morning, and no matter how fast they made that darn thing go, that treadmill go, I couldn't get up above 142. And the nurse says, did you take your beta blocker this morning? I said, yes, ma'am, I think I did. She goes, we need to get up to 145, but you've been on here for 30 minutes and you haven't gotten there yet, so you ain't gonna make it. So we'll have to make do with what information we have on this thing. But next time you do it, don't take your beta blocker. All right. Not necessarily test questions other than examples. Are you with me? For example, atropine. Atropine is what?
Stops.
What does this mean it's going to do?
It stops it from releasing acetylcholine or
No, it doesn't
recepting?
stop it. It acts like it's against acetylcholine. What's acetylcholine going to do? Is that fight or flight or rest and digest?
Fight or
Acetylcholine is rest and
Rest and
digest. Parasympathetic. So why do we say anti? What would against rest and digest look like?
flight.
Fight or flight. Yes or no? That's how we have to think about these things. Okay, now scientists and doctors have a reason for calling it anticholinergic as opposed to pro-sympathetic. Got it? Because this is how it actually works. But if it blocks the inhibitories, right? Remember muscarinic is the inhibitory? If it blocks the inhibitory thing for acetylcholine, what's going to happen? It's going to be stimulated. Instead of inhibited, it's going to stimulate. And why do we use this? We give this drug to prevent people from drooling all the time when the doctor is drilling in your mouth. And remember, who makes you salivate? Rest and digest or fight or flight?
Rest and digest.
Rest and digest. So how do I stop salivating? Stop salivating. Fight or flight. So by blocking the let's digest, it's like, blocking the let's digest, it's like stop digesting. 10-4? Okay. We also use that's the little drops they put in your eyes to check the inside of your retinas to dilate your pupils. Now, they don't use atropine anymore. I asked my eye doctor. She goes, oh no, we used that in the past. The trouble is it keeps your eyes dilated for like the next 8 hours. We use a different chemical now that only dilates for like 3 hours. Does that make sense? So you're not blinded the rest of the day. You got to put those dark plastic things over your eyes so you can at least, drive home, or drive back to work, but in a couple of hours you can go back to work and work. Okay? All right. Neostigmine is a what? Acetylcholine esterase what? Inhibitor. And what did we say acetylcholine esterase does?
It breaks down.
It breaks acetylcholine. So if I don't break the acetylcholine, it stays together in the synaptic cleft longer, and that's why we use it for myasthenia gravis patients. Remember that from chapter 9? Okay. All right. Remember? Myasthenia gravis, we're losing these receptors, but if we can leave the acetylcholine in the gap a little longer, then we can leave those channels open for sodium to come in longer and postpone the debilitating results of myasthenia gravis. Alrighty. Over the counter for colds and medicine and colds and allergies. What do I want to do? Dry this up and open it. Got it? So, who dries up and opens up your breathing?
Fight or flight.
Rest and digest or fight or flight? Fight or flight. Got it? So, they stimulate the stimulatory adrenergic receptors. Got it? And that is why a person with high blood pressure needs to be careful which cold medicines they use, or it'll exaggerate their hypertension. Alright? And we talked about the beta blockers. I'm on this one, propanol. And again, this is to prevent epi from stimulating my heart too much. Got it? It doesn't block all epinephrine, but hey, my heart needs to know there's a train coming. Get off the tracks. Got it? But I don't want any little thing to make my heart beat too fast. 10-4? All right. Okay. I had this up here many times, and I didn't really, say memorize this. Don't memorize this. But there are two words I want to make sure you are very familiar with. Okay? Why? Because it'll help you in 211 and definitely in nursing. All right? And that is these two words, sympathomimetic and sympatholytic. I think we talked about sympathomimetic the other day, right? Sympatho obviously means what? What am I going to deal with? The sympathetic nervous system. Sympathomimetic means I'm going to mimic. It's going to act just like fight or flight. It's a drug that acts like fight or flight. And the sympatholytic comes from lysis. What is lysis?
To
Break it apart. So this is going to act just like it, and this is going to act the opposite of. Are you with me? So if you are taking a medicine that is labeled as a sympathomimetic drug, what's that going to do to your heart? Speed it up. So these are the kind of things you need to explain to your patient why you don't want to overuse this drug. 10-4? What would you tell your patient about if they were prescribed a sympatholytic drug? Well, if your blood pressure is low, it might go lower. Does that make sense? And again, this is just a broad category of what the consequences are of taking that medicine. Now, obviously, those medicines exist because there's a reason for the patient to take it. But we, as informers of our patients, that's what you do as a nurse. You are the go-between between the doctor and the patient. Think about it. The doctor's going to go in there, well, you got to take this drug, right? And as soon as he walks out with his Harvard-sized words, they're going to turn to you and say, what did you just say? Well, what does that mean? Well, do they want you to say the same highfalutin words or break it down in plain English? Okay? So you're going to say, oh yeah, he's warning you this could raise your blood pressure. He's warning you this medicine could lower your blood pressure. Okay? Now, besides blood pressure, what else would this do?
speed up your heart.
Besides speed up your heart and your blood pressure, what would this do? What happens to your digestion? Speeds up or slows down?
Slows down.
So, what do I call a slowed down digestion? Patient? Never heard of that? Yeah. A lot of medicines will give you constipation. So take more fiber. Don't eat too much junk food. Are you with me? And what would this one do to your digestion?
Speed it up.
Yeah, so you might be going to the bathroom a little more often than normal. Maybe a little more loose stools. Ever heard of that? Yeah. Does that make sense? These are to give you an idea of what the consequences are of taking that medicine. Got it? We call them side effects. The main effect is why you're taking it. It's to help you with your cold. The side effect is the consequences of taking this. 10-4? Is there only one cold medicine? Only one heart medicine? Only one asthma medicine? No. Why are there lots of them? What do you think? Be clinical.
In case one gives you worse side effects?
Exactly. We always prescribe to the patient the original. And then we say, patient, tell us if you have any side effects from using this. If not, we keep you on it. If yes, then we're going to switch you. Got it? And if that gives you, we switch it again. Does that make sense? And that's why there's multiple versions of these drugs. Alrighty? Who's got their cell phone nearby? Grab your cell phone. I'm going to actually have you use your cell phone in class and look up beta blockers. Examples of beta blockers. And you'll see there's like 12 of them. It's not just one or two. Okay, now, what do most beta blockers end with? LOL. That is that's a preview of how you need to learn all your medicines in nursing school first semester pharmacology. Would you rather learn all 12 of those things individually, or just say everybody who ends in LOL is a beta blocker and therefore does this? Okay? Look up ACE inhibitor. ACE inhibitor. 2 words. Again, what do you got? 8, 9, 10? What do they mostly end in? Prill. See how that works? This is what they're going to tell you in nursing school. This is what I tell you in Bio 210 and 211. Don't learn all of your pharmacology stuff the hard way as individual drugs. Okay? Learn it by the classification. The Prill, the LOL, the whatever at the end is the designation for what it is. Are you with me? Okay. One more. Look up monoclonal, one word, antibody. Second word. Monoclonal antibody. Do you see things like Keytruda and all that kind of stuff? Those are the sales names, which mean zero. They mean nothing. They're letters thrown together so they make a commercial out of it. But what are the real science words? You might see them in the parentheses. What do the scientific words all end in?
MAB.
MAB. For what? Monoclonal antibody. Nivolumab. Whatever. MAB. And these are the ones that are on commercials a lot for cancer, for asthma, for psoriatic arthritis. Because these are antibodies artificially created in the lab to try to stop your white blood cells from attacking your own body. Autoimmune diseases. And that's the newest form of medicine for you. Okay? But again, you can tell what they are by their ending. Why do you think Mr. Weber is pushing you all the time? How do you know something is a protein?
Ends in I.
Ends in IN or INE. How do you know something is a lipid?
It ends in or has
It has
ester.
ester in the name somewhere, right? Or ends in OL, not LOL, but OL, like cortisol, cholesterol. Are you with me? Okay. Because that is how they're named to make it simple for the pharmacology people to talk about. So why not use that so we can learn it faster? It's the endings. Okay, now, watch this. Just a progression. You tell me, what does a parasympathomimetic drug do?
It copies the parasympathetic
Yeah, it
nervous
copies parasympathetic. What would a parasympatholytic drug do?
system. Prevent
The
or
opposite of rest and digest, which is automatically fight or flight. See? And that's why this chapter is challenging, but if you step back, it's not. You've only got two facts. It's fight or flight, or it's the opposite, rest and digest. It's either sympathetic or it's parasympathetic. 10-4? It's either norepinephrine or acetylcholine. Okay, so just keep that in mind. All right, see, sympathetic increases heart rate, respiratory rate, inhibits digestion, inhibits what? Elimination. See, there's your constipation part. That's fight or flight. Okay? Think about it. You're running away from a saber-toothed tiger. Do you want to stop and take a... Yes or no? No. So your digestive system says, I'm not going to waste time making poopy. But have you ever heard of being scared? Ever heard of that? Because if there is already poo-poo or pee-pee in the two holding areas, your rectum is the holding area for your poo-poo, and your bladder is the holding area for your pee-pee, when you are scared, those sphincters open to lighten the load, and then you can run away. 10-4? The poo-poo in your rectum has already been made. The pee-pee in your bladder was already made. Okay? Has anybody ever, as a kid, picked up a frog or a turtle? What's the first thing they do?
use the bathroom.
They use their bathroom on you, don't they? In your hand. Because they're scared to death. They think your hand is a big mouth getting ready to eat them. So the first thing they do is let go of their poo and pee. Now, I saw this with my own two eyes because my golden retriever puppy, when I was a kid, was playing with a frog, and I said, get away from the Alvin, his name was Alfred. I said, Al, get away from that, Alfie, get away from that frog. And the next thing I hear, ah, and he comes running back to me, his mouth is all foamy. Why? Because he put the frog in his mouth, the frog peed in his mouth, and he went, that's horrible. Which is exactly, does a frog have teeth and claws and scales to fight back with? No. So when somebody's trying to eat them, they just poop in their mouth. And while you're gagging, he pops away. Got it? So, same thing with a turtle. He's too slow to fight back. So, okay, you grab him, I'll just pee on you. Maybe it'll scare you off. And then I can wander away while you're gagging over there. Does that make sense? Okay. So, sympathetic. Decreases the heart rate, decreases respiratory rate, but allows your digestion and the discarding of wastes to increase. Okay? More saliva, not less. More poopy, not less. More pee-pee, not less. Got it? So, if you're taking a drug that is parasympathomimetic, another thing you need to tell your patient about is you might be going to the bathroom more often. You know, you might have to get up in the middle of the night and go pee more often. Okay? Okie dokie. Now, sympathetic tone, what does that mean? This means that one nervous system sets the tone. No problem, come on, boy. Sets the tone for one particular action in your body. And That's this for your blood vessels. The sympathetic nervous system is always ready to make your blood vessels tighten up, to bring up your blood pressure so you can run. Got it? Get that blood quickly to your arms and legs. Got it? So it's always ready to tighten up. Sympathetic tone for blood pressure. And of course, blood pressure is caused by your blood vessels being constricted. Think about it. When you were a kid and you were playing with the garden hose and you want to spray somebody that's over there, do you just aim the hose, or do you put your thumb over the hole or make the hole smaller? When you make this hole smaller, doesn't it shoot farther? Because it increases the pressure. Got it? Okay. Yeah, we got the blood pressure. We got that. Okay. Now, how about your sympathetic tone? Believe it or not, your sympathetic dominates the heart and your digestive system. Do you want your heart going like this or being more calm? So your vagus nerve is saying, hey, heart, slow down to 72. Got it? Let that be the rest. And, hey, digestive system, I'm in charge of you, so do what you got to do. Eat today and poop tomorrow. 10-4? All right. Now, can the sympathetic override that? Yeah. In the middle of fight or flight. Yeah, we'll shut this down and say, we're going to take over. All right. And see, drugs that block parasympathetic increase heart rate, block fecal and urinary retention. Okay? These are all things to give you an idea of what we're going to do in 211 next semester and in nursing school after that. All right, cooperative, remember we told you the parasympathetic is in charge of the erection, but the sympathetic is in charge of the ejaculation. So sometimes they work hand in hand. All right? All righty. Yeah. Your sympathetic is coming mostly out of your adrenal medulla. That's the middle part of the adrenal gland. Hence the name adrenaline. Proteins from your adrenal gland. Got it? Adrenaline. And they are all about make sure we release renin from the kidneys, increase your metabolism, jack up your blood glucose so you can have plenty of glucose to make ATP for your muscles. All right. Now, who lasts longer? Rest and digest or fight or flight? Believe it or not, fight or flight takes hours to get over. Rest and digest takes seconds to get over. Sort of like there's an old hymn from my church days when I was a kid. In one of these things, it says, days of toil and hours of ease. So more sympathetic and less rest and digest happening. Why? Does anybody know why? When you're, oh my God, it takes a long time to calm down. Because it takes enzymes and whatnot and the liver to eliminate epinephrine and norepinephrine from the blood. Got it? Sympathetic is longer lasting because it's inactivated more slowly. Got it? They're released into the blood and they remain there until they're destroyed by the liver. So you're jacked up for a long time. Anybody ever been in a situation like a car accident? You don't just immediately calm down, do you? You're like this for a while. Yes or no? But rest is over. Why? Because acetylcholine esterase snips your acetylcholine immediately. So you're not at rest as long as you are jacked up. Are you with me? All right. Now, who is the guy in charge of all of this autonomic nervous system? Who? The hypothalamus. Okay? The hypothalamus is the boss. Got it? Who's the boss? Hypothalamus is the boss. Alrighty? He's the one that says, okay, rest and digest, off you go. Hey, fight or flight, go. Hypothalamus. Okie dokie. That's why it controls all sorts of things like your heart rate and your blood pressure and your temperature and your water balance. It controls your hormones, your emotional stages, hunger, thirst, sex drive. Got it? And reactions to the fight or flight system. Alrighty? Who are we going to dissect next week out of our brain?
Sheep.
I know. Who are we going to cut out of that brain? The gateway to learning. Remember hippocampus? Because he's also part of your limbic system, your emotions. But this is your emotions not driving your heart rate, but emotions driving your study rate. Okay? All right, and of course, as we get older, well, I can't wait. Now, this is a cool word, and it's probably going to be a test question. If it's not going to be here, it will be in 211. So, orthostatic hypotension. Let's break the words down. First of all, what's hypo?
Low.
Low. So hypotension is low pressure. Tension, blood pressure. Got it? Not just tensing your muscle, but tensing the smooth muscles. So low blood pressure. Caused by what? Well, let's look at the word ortho. I want my teeth to be straight, so I go to see a who?
Orthodontist.
Orthodontist. I need to have my leg straightened because it's crooked. Who do I go see? Orthopedist. So what do you think ortho means?
Straight.
Straight up and down. I mean, you don't want your teeth going like this, do you? Or your leg going like that, do you? It's straight. And static means to stand. Stand straight. So what is orthostatic hypotension? It's for a person who's got low blood pressure. If they stand up too fast, orthostatic, the blood pressure in their brain drops and they get dizzy and might fall. Got it? And that's usually older people. But it can happen to anybody. If you stand up too fast, the reason you get a little dizzy is because you have drained the blood. Gravity has drained the blood out of your head. Okay? So you got low blood pressure up there. Does that make sense? And that is why your first clinical, which will be with nursing home patients, please help Mrs. Jones get out of the chair and get out of bed or get off the potty. You don't want Miss Jones falling, cracking her head on the floor of the bathroom because you're outside having a smoke break. Your job is to be with Miss Jones. Does that make sense? Because older people are more susceptible to this orthostatic hypotension. Cool beans? All right. How about that? Done. Thank you, sir. All right. Save that one.